Rohit from Team Cloud9. I'm going to walk you through how Sentinel proxy handles data exfiltration. Later we will examine how our proxy handle different types of attack scenarios. So the problem is standard security stops hackers from entering. It doesn't stop them from leaving with your data. If a hacker gets an admin token, they can download the entire user's table of millions of rows in one go. Now let's trace how a request actually moves through the system. So when the client sends an HTTPS request, the proxy intercepts it and immediately opens a high-speed gRPC stream to the backend. When the app server sends data back in binary chunks, we don't buffer them to check later. We process them in flight. Now looking at our logic loop, for every single chunk that passes through, we increment the user's byte count and cross-reference it with Redis in real time. We are constantly asking, does this fit their normal early behavior? If we detect an anomaly, the loop breaks instantly and we trigger a TCP RST signal to close the connection immediately. Now naturally the first question we get is about performance. Nobody wants a security tool that slows down production, right? And this is where Sentinel proxy stands out. Our design choices make sure it doesn't become a bottleneck. So we are using gRPC for connection between the proxy and the backend for high-speed professional-grade data streaming. To keep our logic just as fast, we use Redis sorted sets for the sliding window. But the real differentiator is about in-flight handling. By using io.t readers from Go standard library, we bypass the buffer, then analyze that. This ensures one memory complexity. Now let's simulate different attacks on our proxy. You can see the live log feed on the left side of the screen. First we see Alice. She is just checking her dashboard. Sentinel identifies her via a JWT token, checks her history and sees her 131 KB request is normal. She finishes in under a second with zero lag. Now an attacker uses the stolen keys to dump the entire database. Sentinel detects a massive velocity spike. Within 353 milliseconds, the proxy kills the connection. We stop the leak before even 10% of the data got out. Now we don't want to block people for accidental spikes. Sentinel uses 3 strike system. First a log, then a throttle, and finally a termination if they don't stop. Now, if the attacker tries to go anonymous by stripping their credentials, Sentinel falls back to IP fingerprinting. We still recognize the device and apply the strictest limits immediately. Finally, everything is visible. We export live matrices to the Prometheus. If a breach happens, the security team sees a spike on their dashboard instantly. Now let's address an important edge case. What if admin is hacked? So if an admin account suddenly behaves abnormally, Sentinel will detect the unusual data volume and slow the transfer. Looking ahead, we plan to integrate an MFA challenge at that point, so a legitimate admin can quickly verify and continue, while an attacker with just a stolen key won't be able to proceed. So in a nutshell, we don't wait for a weekly audit to find a breach. We stop the leak in milliseconds before it becomes a headline.